Okay, we're on number 7, and we read, tell whether the function represented by each of the following tables is an inverse variation. Now there's several ways that we can determine that. We can determine it by putting our formula or our form up there and determining whether or not it fits into the form for each of those values, x and y values. There are a couple of other things that we can look at as well. We can actually plot them to see if it forms a curve. Okay, we wouldn't necessarily need that. And there might even be another thing or two that you'll immediately spot and say, oh, that cannot be an inverse variation. Okay, so let's take a look at the first one. We have an we have x and y values of 1. Let's put it up here. X and y values of 1, 24. Well, we go 1, 2, 3, 4. It's always the easier way. And then we go 24, 12, 8, and 6. Well, firstly, remember we said that as the x value goes up, the y value should go down. Okay? And it's important to remember that. Um, and we notice also that they behave a certain way. When we double a value, we're halving it. So in this case, I see this value doubling from 1 to 2, and I see the y value is going half. When I go from 2 to 4, I'm seeing the same thing happen. When I'm tripling it over here from 1 to 3, I'm dividing by 3. So I'm seeing everything really working in action. Maybe I can go ahead and plug some of this information and say, well, the y value here is 24, right? That's the first one. And so what is a if x is 1? Well, the answer there will be 24. So our a value apparently is equal to 24. Does it work for the other ones? No, let's see. Well, let's say y is equal to 24 divided by, let's say, x. That would be 2. Yep, that's equal to 12. That works. Y is equal to 24 divided by 3, and that would be 8. Yep, that works. And y is equal to 24 divided by 4, and that would be 6. So they all work. So I would pretty much say we've done quite a bit of investigation here. I think we found out that this is in fact an inverse variation. So let's move on to our next one. And let's just take a look. I'm going to erase this one off the board. And we're going to look at the first value. X is equal to 0, 1, 2, 3. Wait, hold it. Wait a minute. X is equal to 0. We already know that x cannot equal 0. Okay? Right there alone, we spotted a problem. We know that x could never be equal to 0, so this cannot be an inverse variation. You can knock that one right off the board without even looking at the numbers. Okay? Let's move on to C. C is, we have 1, 2, 3, 4, 5. All right. 1, 2, 3, 4, and 5. Then we also have 32. We have 16. We have, let's see, 8. We have 4. And then we have 2. All right. Now, what do we have going on here? Well, what happens when we multiply, for instance, by 2? Well, we're dividing by 2. That works. What happens when we triple? Uh, let's see. We're dividing by 4 here. That's a little bit different. Okay. I also notice here that when I double this one, I'm not halving this one. This is actually divided by 4. So there's something completely different going on here. And if we were to determine what these values are, we can try to find, let's see, we have a 32, which is a y, and that's equal to a divided by 1. So a is supposed to be equal to 32. So let's put that there. So y is equal to 32 divided by, well, let's do 2. Well, that works, 16. What about the 32 divided by 3? Well, that's not 8. That's not going to work. What about 32 divided by 4? Well, it's 8, but not 4. We have 4 here. So this is definitely not an inverse variation because we cannot plug in these values into our formula. So we've already found that out. Okay. Now let's go over to our next one. We have 2, 3, 5, 6. 2, 3, 5, 6. Okay. Now these numbers aren't necessarily going up in the order 2, 3, 4, 5, 6, but that's okay. Let's just see how the numbers are behaving. We have 15, we have 10, we have 6, and we have 5. Now, when we're doubling, the only doubling I see here, excuse me, is 3 to 6, and I'm definitely seeing it's halving. And when I triple from 2 to 6, I also divide by 3, so that's a good sign. Why don't we go ahead and try to find out what our value is. Oops, I have a y value of 15, and I'm saying that's equal to a divided by 2. So what would I divide by 2 to get 15? Or what do I multiply? I can multiply 15 times 2 would be 30. So it looks like our a value here is 30. Okay? Well, let's see if it works for the others. Y is equal to 30 divided by 3, and that would be 10. Okay, that one worked. Divided by 5, it would be equal to 6. That would work. 30 divided by 6 is equal to 5. That would work. So it certainly looks like this is inverse variation. I would definitely say it is based off of the table that we're given there. Okay? All right, let's go ahead and now get rid of this and put our last one up. Sorry about that. Now we're going to start off with our x value is equal to 0. Then we have 1. Then we have 2. Then wait. What's this guy doing here? No, can't do it. They gave us a 0 again. Tried to sneak that by us. No, this is not an inverse variation. We don't even need to investigate any further. So the answer to E is no. All right, so we found out that A and D were inverse variations, and we found out for different reasons that the others were not. Okay.